Hello everyone. In this video, we're going to talk about the distance formula. Now, the distance formula is really important in geometry because it bridges the gap between algebra and geometry. It allows us to take our geometric shapes, put them into the coordinate plane, and then talk about the lengths of their sides. And once we can talk about the lengths of their sides and assign numbers and coordinates to these, we can use all the rules and all the properties we already know from algebra in geometry. The first thing I want to do is I want to derive the distance formula. I want to take a look at where this comes from. So what we're going to start with is we're going to start with an arbitrary graph. Arbitrary, that just means that this can be anywhere in the coordinate plane. And I just want to take a look at 2 points. So let's say we have point A, and then somewhere else we have point B. And let's say that we want to find the distance between these 2 points. First thing, let's connect these together to make a segment. So what I want to do is I want to find out how long this segment is. Well, to do that, let's assign some coordinates to these points. So because we want this to be arbitrary, and we want this to be able to exist anywhere, we're going to use some variables. So let's say that this is the point x1, y1. And then for point B, we'll say that this is x2 and y2. Now the next thing we want to do is I'm going to create a triangle. So from A, I'm going to go straight over to B. So from A, if I follow a horizontal distance over to B, it's going to take me to here. And then let's do the same thing from B. Let's drop a vertical segment straight down to here. And then this new point where these two meet, let's call this one C. Okay. Next, let's talk about the coordinates for C. So the 2 coordinates for this, it lines up vertically with B. So that means it has to have the same x value as whatever B is. If I were to go straight down to here, this is the x value of x2. So like this. And then horizontally, it lines up directly with A. Same idea. If I go straight across, this y value on the axis is y1. So the coordinates of C are x2 and y1. The other important thing to note is that this is a right angle. So because one of the segments is horizontal and one is vertical, they're perpendicular to each other, so we have a right angle here. And if I have a right triangle, I know that I can use the Pythagorean theorem. So the Pythagorean theorem relates the side lengths of a triangle. So just to write this out, so in a triangle, if I have side lengths of A, B, and C, the Pythagorean theorem says that A squared plus B squared is equal to C squared. So the 2 legs, the squares added together is equal to the square of the hypotenuse. So, relating that back to what we have in our coordinate plane, we should be able to use that to find the length between A and B. So let's start by taking a look at this horizontal segment. Horizontal distances, straight distances, are much easier to find. We can just think about this as the difference in the x values. So this is x1 along the x-axis. So how far do I need to go to get from x to x2? So what's that distance? Well, we can find that just by subtracting these 2 x values. So if I take x2 minus x1, that will give me that length. So for example, let's just say x2 is over here at 5, and if x1 was at 1, in between there, that's a difference of 4 units. So that length is 4. But we can find that by doing 5 minus 1. Let's do the same thing for the y values. So here we have y1, and then straight across over here we have y2. And we want to find this length. So how far do I need to go from y1 to y2? It's the same argument we had down here. So this length is just going to be the difference of y2 and y1. So those two distances, those are my a and b in my formula. So if I plug those in, so instead of a squared, we'll do x2 minus x1. And then instead of b squared, we'll do y2 minus y1. And that's equal to the hypotenuse squared. So this is what I'm trying to solve for, this length of AB. Let's call that D for distance. So instead of C, we'll do x2 minus x1 and y2 minus y1 squared. And then this is going to be equal to the distance squared. Well, I want to have the distance all by itself. So let's finish up by taking the square root of both sides. So if I do that, what I'm left with is D for distance is equal to all of this stuff we had before, and it's the square root of all of this. And there's the distance formula. So now let's use the distance formula in an example. So I have 2 points, okay, I have some coordinates. I want to find the distance in between them. The nice thing about the distance formula is we don't need to graph these to find how far apart they are. So just to write down the distance formula one more time. Now, one thing that may help organize your information is just labeling our points. So maybe I'll say that this is x1 and then this is x2. So the first value inside the parentheses, those are your x values. And then let's say that this is y1, and then we'll say that this is y2. When I go to plug these values in, I do need to be careful. Because I have subtraction built into the distance formula, I need to watch that. Order does matter here. So x2, we labeled that as -6. And then we have minus, and then my x1 is -2. So I do have minus and negative here. So this is a situation we need to be careful of. So I'm going to put the -2 in parentheses just so I see that I do need to simplify that later. For the two y values, we said y2 is 1, and then we'll subtract 5, and that's squared, and we have the square root of all of this. So now that we have everything plugged in, we're just going to use our order of operations to evaluate this. We do have to work our way from the inside out. So let's simplify inside the parentheses first. Then we'll square the numbers. Then we'll add them together. And then the very last thing we're going to do is take the square root. So minus and negative, that's going to turn into plus. So we end up with -6 plus 2. Our second set here, 1 minus 5 is -4. And if I keep going, -6 plus 2, that's going to be -4. So we have -4 squared plus -4 squared. -4 squared, -4 times -4 is 16. And then if we add 16 plus 16, we end up with the square root of 32. So there's the distance between our 2 points. The square root of 2, that's going to be a little bit less than 6. So maybe about 5.7, 5.8. But we can also simplify that a little bit further. So the square root of 32, if I want to simplify a radical, what I'm looking for is the biggest perfect square that 32 can be divided by, which is 16. So I can split this up into 16 times 2. The product rule for radicals says I can split that up into the square root of 16 and times the square root of 2. Square root of 16 is the same as 4. I can't do anything with the square root of 2. So here's our answer. Fully simplified distance between those 2 points. So as I said, the distance formula, it gives us a tool to connect algebra to geometry. It gives us a way to find the distance in between 2 points without having to graph it.